Good day, viewers. Welcome to my YouTube channel. I'm your presenter, Mr. Mlenga. So right here with me, I've got Mathematics Paper 1 for 2022 external candidates. So to those who have been following me, we did our first part, okay, where we answered questions from question 1 up to question 10. So today, I want us to look at question 11 going up. So we are starting from question 11A, okay, there is also B. So given that the E is a universe set which contains these elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And set A is a set of prime numbers, and set B is a set of multiples of 3. List A union B in brackets, complement there. So in order for us to answer this question, what we are going to do is we are going first to identify the elements that are going to belong to set A, which is a set of prime numbers. So you know that prime numbers are numbers that have only two factors, that is 1 and itself, okay? So from this universal set, let us identify the prime numbers. So 1 is not a prime number, okay? So 2 is a prime number, it's here. 3 is also a prime number. 4 is not a prime number because it has more than two factors, okay? And it's divisible by 2. 5 is a prime number, so we write 5. So from 5 here, 6 is not a prime number. 7 is a prime number, so I write 7. 8 is not a prime number, okay? 9 is not a prime number. 10 is also not a prime number. So we end here. This is our set A. So these are the prime numbers that we have in set A. Now let us identify our set B. Let us identify our set B. So set B, they have told you that we are looking at the multiples of 3. So the multiples of 3, we are going to start from 3 itself. From 3, we come to 6, okay? 6. From 6, we come to 9 right here. 9 is a multiple of 3. So these other numbers 10, 1, 2, 3, 10, 1, 2, 4, 5, 7, 8. These are not multiples of what? Of 3. So the only multiples of 3 from this universe set are 3, 6, and 9. Now from here, the question is find A union B in brackets, complement. So first thing, let us find the A union B. So we say A union B. We find A union B first, equal to. So A union B simply means we combine the elements that are in A with those that are in B. So in combine these, we are going to have 2, okay? So 2, 3, 5, 7. So 2, 3, 5. So I also put the 6, 6, 7, 9. Okay, then I'll cross like this. This is A union B. I've just combined the elements that are in A with the elements that are in B. So those elements that are appearing twice, you can see 3 is here, 3 is here. There's no need for you to write it twice. Just write it once, okay? That's all. So this is A union B. Now from this A union B, let us now answer A union B complement. In brackets, A union B in brackets, and then the complement outside. So what it means is A union B in brackets, complement. So complement simply means that the elements that are going to be in A union B complement, okay, should not be part of the solution set, okay, that are from A union B from here. So you can see you have the inverse set here, then you have A union B from here. So the complement are the elements that are going to remain from the inverse set because they are not in A union B, okay? That would be our answer. So we can cancel from the inverse set, where we can say, you can see here we have 2. We said we do this, even here we have 2. We can be cancelling like this. We have a 3 right here, we can cancel. Even there from the inverse set, we have a 5, we can cancel. Even here, we have a 6, we can cancel. Even here, we have a 7, we can also cancel a 7. We have a 9, you can also cancel a 9 like that. So the elements that we are remaining with in the inverse set, that is A union B in bracket complement. So we are remaining with a 1, a 4, 8, and 10. So we write 1, 4, 8, 10. That is what we are remaining with. So this is our answer. Okay, so we have answered this question. I hope it's clear. All right, let us now move on to question B. So we have answered our question A. We now come to question B. So question B. Question B reads, on the diagram in the answer space, so this is the answer space right here, draw triangle Q, the image of triangle P under a reflection in the line y is equal to negative x. So this is the diagram which is right here on the answer space. I don't know if it's clear. Okay, let me just move it. Yeah, it's clear. All right, so here we are looking at the reflection. Okay, this is reflection transformation. So they have given you what we call a mirror line. Okay, in the line y is equal to negative x. So first thing, identify where this line is. So this is our Cartesian plane that we have been given. So where can we find the line y is equal to negative x? Okay, so let us identify where. So y is equal to negative x. It passes right here. Okay, it passes right here. Then here, this is where you have y is equal to x. So you have to know this. So I've said y is equal to negative x. It will pass right here. Okay, it will pass right here. I want you to see clearly. Okay, this is where it will pass. So this is the line y. This is the line y is equal to negative what? X, like this. Okay, so upon doing that, now let's move on. Since we are looking at refraction transformation, so you have to know what refraction transformation is. Okay, so you have the image right here. This is the image, okay, and it's called P. So they want you to find the reflection, okay, of this image. Now, when these points are passing from, let's say this point right here, when it's coming to this other side, okay, what you are going to do is this: identify the point that you have. Okay, so here you have 3, 0. This is the point that you have. Then here you have, this is 3, this is 3 right here. So here you have 3, 3. Okay, then here what do you have? We have a 1 here in the x-axis, 1 in the y, 3. So here we have 1, 3. So there are different methods that you can use to find the object, okay, which will be under the reflection in y is equal to x for this image. Okay, so since here you have 1, 3, what you can do is this 1, 3, it will transform. Okay, it will be negative 3, negative 1. So let's map this. I'm saying this will be our image. Okay, so this is our image now. Negative 3 is right here, then negative 1 will be right here. So we are going to have a point right here. Okay, you have seen. Then from here we come to this point right here, which is 3, 3. So 3, 3. So 3, 3 will be negative 3, negative 3, since both numbers are the same. So negative 3 is right here, then negative 3 will be right here. Okay, you have seen. I'm making dots here. I've made 1 here and 1 here. Then we come to this point, 3, 0. So this point, which is 3, 0, we are going to say 0, negative 3, because you can't say negative 0, negative 3. 0 is a neutral number. Okay, so neither a positive nor a negative. So 0, negative 3. So x-axis 0, it's this line. x is equal to 0, the negative 3 will be right here. Okay, so what you do now is you have identified these points. Okay, so that is the reflection you are going to have under the line y is equal to negative x. So what you need to do is just get your ruler. Okay, you get your ruler, then you connect these points like this. So we connect here. I hope we are together. We also connect right here. Then we also connect right here. Okay, so so this will be called triangle at Q, like this. Okay, I hope it's clear. Now, from if you don't want to use this method, since you know that a reflection is a transformation in which any two corresponding points of the object and the image, okay, the object and the image must have the same distance, okay, from right at the right angles to a straight line called the mirror line. So to this mirror line, so the distance from this image to the object should be the same. You can also use that method, whereby when you move from this point which was here, okay, so you count the distance that you move from this point reaching up to the mirror line, also from this mirror line up to this point. Okay, I hope it's clear. So you move like this. Here you count as 1, 2. You have seen. Even here you move 1, 2. You can see the distance is the same. Okay, so you can also use this point whereby you identify that the distance from here to the mirror line is the same. You have moved 2, 1, 2. Even from the mirror line coming this side should be 2. So 1, 2, same distance. Okay, then you can mark your point here. Also, you can do the same from here. You see the distance when you reach on the mirror line. Okay, then from here you also do that. Let's check. So this is our point. When we are moving from here, we say we have 1, okay, 2, 3. You have seen 3. Again from here, let us move. We have reached the mirror line. Say 1, 2, 3. It's also the same. So then you make a point right here. Okay, so even here when you count, it will be the same. From here you say 1, then here we have 1.5. Okay, then again from here we have this half, then 1. You can check, they are corresponding, they are having same distance. Then you identify your points, this and this and this. Then you draw the object like this. You even label it as triangle Q. So both methods can work out. So you can either use whereby you use these points, you change them like this, then you add the negatives, or you just measure the distance. It's fine. Okay, so we have answered our question 11. Let us now move on to question 12. Okay, so this will be our question 12. Question 12 reads, a piece of wood measures 25 centimeters long. Find the, so question A, they want you to find the upper and the lower limits. Okay, so we are going to start with question A. We start with upper limit. So upper limit. Okay, so what do you do when you want to find the upper limit? So to find the upper limit, the formula is just you say true value plus the absolute error. So true value, TV, T stands for true, V for value, true value plus absolute error, like this. So from here, it's important that you take note of something. Here, the true value is 25 centimeters, which is a whole number. So if you're having a whole number here, if you have a whole number, the absolute error, okay, for the whole number, the absolute error for the whole number will be 0.5, like this. It will be 0.5. That will be our absolute what? Error. So from here, let us proceed. The true value is 25 centimeters. So when you are finding the upper limit, you are supposed to add true value plus absolute error. So 25 plus 0.5 centimeter, like that. So when we add this is paper 1, we say 25.0 plus 0.5. Make sure you arrange nicely. So here it's a point, here 5 plus 5, it's a 5, and then we have a 2. So here our upper limit will be 25.5 centimeter. Okay, I hope we are moving together. We now come to question B. So question B, where we are supposed to find the lower limit. So lower limit. So when you know how to find the upper limit, to find the lower limit is just the same, it's opposite. So you get the true value, which is 25 minus 0.5. Okay. Right. So I've said when you are finding the lower limit, okay, when you are finding the lower limit, it's just the opposite, where you get the true value, then minus the absolute error. So in this case, the true value is 25 minus our absolute error is 0.5 centimeter. So don't forget to subtract nicely. So you just say 25.0 minus 0.5, like this. Very important. So you put a point here, 0 take away 5. It can't, so there's need for you to borrow from this 5 a 1. So here you remain with a 4. So you say 10 minus 5, it's 5. Then 4 minus 0, it's a 4. 2 minus 0, it's a 2. Okay, so our lower limit here will be 24.5 centimeter. All right, so we have answered our question A right there. Let us now come to question B, percentage error. So how do we find the percentage error? How do we find the percentage error? So follow me nicely. Allow me to create space right here for percentage error. So how do we find the percentage error? So the percentage error can be found using different methods, where you say percentage error equal to, so this is the formula, percentage error equal to, so you can get the absolute error over, I hope we are moving together, true value, then times 100%, because this is percentage error. So what you are going to do now, your absolute error is 0.5 centimeter over the true value is 25 centimeter times 100%. I hope you are following. So you can cancel this percent. Okay, so from here, what are we going to do? This is very easy. There are different methods that you can use. If you want, you can multiply 0.5 times 10, even down times 10, so that to get rid of the decimal number. Then you simplify, you also multiply by 100%. Or you check in the diagonals. 25 can go into 100 without giving you any remainder. So you say 25 here, it's a 1. Into 100, it's 4. So we are remaining with 0.5 times 4% this side. So you say 0.5 times 4%. So the moment you multiply 0.5 times 4%, you are going to get 2.0%. So our percentage error right here will be 2.0%. Okay. Now come to question 13. So given that fx is equal to x minus 4 and hx is equal to 2x plus 3, find h inverse of x. So you can start with question A right here. They want you to find h inverse of x. So h inverse of x. So first thing, write the function of hx, which is this. Hx is equal to 2x plus 3. So from there, what you need to do is to make x the subject of the formula. So how do you make x the subject of the formula? You are going to introduce this variable y equal to, then you say 2x plus 3. So from here, since we want to make x the subject formula, so this positive 3 will go to where y is. We're going to have y minus 3 is equal to 2x, like this. So from there, what's next? From here, what's next? Since we want to remain with x this side, there's need for us to divide with the coefficient of x, which is a 2. Okay, so these 2 and these 2 cancel, therefore x is equal to y minus 3 over 2. So what are you going to do there? This is what you are going to do. Your final answer therefore is going to be h inverse of x is equal to, so here right here where is y, you are going to put x, where you say x minus 3 over 2. So this is our h inverse. Alright, so let us check our question B. So question B is right there. Okay, this one, you have to find the h inverse of 5. So this is our question B. So to find the h inverse of 5 is very simple, because we have found the h inverse of x. So the h inverse of x that you have found is h inverse of x is equal to, we have said, oh sorry for that, it's not supposed to be 3, but supposed to be x. Alright, okay, so it's supposed to be x. Alright, so it's equal to, so it's supposed to be x, where we said x. Alright, x minus 3 over 2. So this is the h inverse of x. X minus 3 over 2. So they want you to find the h inverse of a 5. So it means on this same function where there is x right here, we are going to substitute 5, where we say 5 minus 3 over 2. Okay, so from here, this is what we are going to do. We'll say h inverse of 5, h inverse over 5 is equal to 5 minus 3 is a 2 over 2. So here 2a1, 2a1. So this will definitely give us a 1. So h inverse of 5 is a 1. So let us see how we can answer the last question now. So this is our last question, which is right here. Okay, this is our question. They want you to find h fx. Alright, so this is a composite function. Okay, we are now on question C. So remember our functions first, we have fx, which is equal to, let me check our function, fx, which is equal to x minus 4. This is equal to x minus 4. Then we have function of hx, which is equal to 2x plus 3. Okay, which is equal to 2x plus 3. 2x plus 3. So they want you to find the h f of x. Okay, this is what they want you to find. So what it means is this function of f is going to compose the function of what? H. Okay, so the function of h is we have 2x plus a 3. Okay, so from here we're going to say, since we understand that the function of f is going to compose the function of h, so right here where there is x on this function of h, we're going to put the function of f. So I'll write 2 open brackets. So where there is x, I'll put the function for f, okay, which is this one, x minus 4. So I'll write x minus 4, I cross, then plus 3, this 3 right here. So from here, let us just expand 2 times x. We have 2x. 2 times negative 4, going to get negative 8. Then plus what? A 3. Okay, so I hope we are moving together there. So from here, let us just work out the like term. So equal to 2x negative 8 plus 3. We are going to get a negative 5. This is our function of HFX. All right. I've now come to question 14. So this is a question that has to do with bearings. The question reads, in the following diagram, P, Q, and R are 3 points on level ground. The bearing of P from Q is 228 degrees. Angle QPR is equal to 72 degrees. Angle QPR, the angle which is right here, is equal to 72 degrees, and R is due south of Q. R is due south of what? Q. Okay, so the questions are, find the bearing of the first one, Q from R. They want you to find the bearing of Q from P, sorry, Q from P. Then they want you to find the bearing of P from R. P from R, okay? So what I'm going to do first is, you can see here we have our north direction, not so. So I will just extend this line down here. Just extend this line like this. Then even here, you can check we have our north here. So I'll also extend the line from here like this. Okay, that is the only thing that I'll do first. So from here, what am I going to do before I even try to answer these questions? Let's see. We have this angle. Okay, we have this bearing, the bearing of P from Q, the bearing of P from Q. So all the way from here coming to this line for Q is 228 degrees. So this is for everything right here, not so. It's for everything right here. So we need an angle just to be here, an angle here. So I'm going to consider this is a straight line. So from here up to here, this is 180. So for me to find the angle, it should be right here. What are we going to do? Okay, what are we going to do? So since this is 228, so just get this 228 degrees minus, okay, minus what I've said. This is a line which will give us 180. So we'll get this 228 minus 180 degrees, and this will give us a 48 degrees. So you know that from here to here, this is a 48 degrees, like that. So you can use this idea, okay? You can use this idea. Then if you have a 48 here, these are alternate angles. The angle which is right here and the angle which will be right here. These are alternate angles. So if you have a 48 here, it means that even here you're going to have a 48 degrees. Okay, I hope it's clear. So another way that you can find this angle that is right here, since here this is a triangle, and you know that angles in a triangle, they add up to 180. So if you add this and this, then subtract from 180, you find the angle which is here. So when you find the angle which is here, to alternate with the angle which will be right here. So when you say 72 plus the angle which will alternate right here, then subtract from 108 to give you a 48 as well. You can use that, it's fine. Okay, you can use that, it's fine. So let's find an angle which will be here so that it will help us. Okay, so what are we going to do? I've said the sum total of angles in a triangle, they add up to 108. So when you add this and this, you must find an angle which will be right here. Okay, so we'll just say 180 degrees minus, so when we add a 72 degrees plus 48 degrees, which is right here, okay, so this will definitely give us a what? A 60 degrees. So this 60 degrees will be right here. So this 60 and this, they are alternating. So if you have 60, even is 60. So you can add this and this, subtract from 180, you can get 48 right there. Okay, if you don't want, you can use this and this, which is just straightforward. So let us now check our questions. Find the bearing of Q from P. Find the bearing of Q from P. Q from P. So since the bearing of Q from P. So Q from P, we are starting from here, from this line until we touch this line for Q. Okay, this is the bearing that they want us to find, and we have said the bearing here is a 48. Okay, so it means the bearing of Q from P, this one, is equal to, we just say 0, 48 degrees, because we are dealing with the 3-figure bearings. Okay, we have answered this one. Now let us come to the second one. Find the bearing of P from R. P from R, So where they have told you from, that is where, since we have our north here, so we are considering this line now all the way from here until it touches the line for P, like there. That is the bearing they want us to find. So we know that the complete angle here, the complete angle is 360, but here we have a 60. So we can say 360 degrees minus a 60 degrees, and this will give us a 300 degrees. So the bearing of P from R, okay, the bearing of P from R, this will be a 300 degrees, which is very easy and straightforward. So I hope that it's clear. 15 consists of question A and B. So I'm going to start with question A. Okay, a line passes through the points A and B. So point A is having negative 2,5, which is a coordinate. Also B is having 0, y, which is a coordinate. Given that the gradient of line AB is negative 3, find the coordinates of B. Okay, so you can check here. B, we have these coordinates 0, y. So we have the x coordinate. Now there's need for you to find the coordinate representing y. Okay, so how can we answer this question? So allow me just to do something like this. Let me just market. Okay, then we can answer. Okay, so how can we answer it? So we're going to start with question A. Now on this question A, they are telling us that we've got point A, which is having negative 2, negative 5. Okay, then we also have point B, which is having 0, y. Okay, so they have told us that the gradient of line AB is equal to what? A negative 3. These are very important points to take note of. Okay, so from here, what we are going to do is, let's just assume that we are finding the gradient of line AB, where we say gradient of AB is equal to, so this is the formula for gradient, where you say y2 minus y1 over x2 minus x1. I hope we are moving together. Now from here, from these coordinates that we are given, okay, you rename them. This is your x1, this is your y1, this is your x2, and this is your y2. Okay, so they have given you that the gradient of this line AB is negative 3. So write on this formula that you have come up with, where you have gradient of AB, you are going to replace with negative 3. Where you have y2, what will be your y2? It will be this y. Then what will be your y1? It will be a negative 5. Then what will be your x2? It will be a 0 right here. Then what will be your x1? It will be a negative 2 right here. So that is what we are going to do. Okay, it's just to replace. It's just a matter of replacing. So our gradient, they have told us that it's a negative 3 equal to y2, we have said it will be y, minus y1 is a negative 5, so we should put it in brackets, over x2, it's a 0, which is right here, minus x1 is a negative 2. Put it in brackets as well to avoid complications. Okay, now from here, let us open the brackets where we say negative 3 is equal to y, negative times negative, we are going to have a positive 5 over 0, negative negative, we are going to have a positive 2 right here. So from here, what are we going to have? From here, what are we going to have? So from here, you can say we are going to have negative 3 is equal to y plus 5. We can't add these unlike terms over 0 plus 2. It's a 0. So we can do this. Then we cross multiply. Okay, so that we find the value of y. So what are we going to do here? So do cross multiply. We say 1 times y plus 5. We're going to have y plus 5 equal to negative 3 times 2. You're going to get a negative 6. From here, we collect the like terms. So the like terms are 5 and a negative 6. So this y will remain here. You're going to have negative 6 minus a 5. So the reason why this is a negative 5, because it was a positive 5 right here. When it comes this side, to be a negative 5. So here, what will be our answer? Y is equal to negative 6 minus 5. This will give us a negative what? 11. This will be the value of y. Okay, so remember, they want you to find the coordinates of b. So the coordinates of b, if you remember, they were 0, y. So just replace. Okay, just replace. Where there is y here, you're going to put negative 11. So your final answer will be the coordinates of b, they are going to be 0, negative 11, like this. So this is our answer right here. So I hope it's clear. Okay, this will be our answer right here. So that is how you can find the coordinates of b, which will be 0, negative what? 11. Let us now come to question b. All right, so we've now come to question b right here. This is our question b. In the diagram, ABC is a straight line. So ABC is a straight line. Angle BCD. Okay. All right, so we are saying ABC is a straight line, ABC. Angle BCD. So angle BCD is equal to 90. There is a 90 degrees right here. And tan ABD is equal to negative 3 over 4. So tan ABD. Okay. So here you must know that the tan will be outside here. Okay, that's why it's even having a negative. Okay, so this tan, which is the angle which is outside here, is negative 3 over 4. So when we take it inside now, it's going to be 3 over 4. It will be a positive. Okay, so here tan was either in the second quadrant, second and the fourth. That's where tan is negative. So when you take it back inside here, to be a positive angle. All right, so from here, what we must know is when we have an angle right here, so this side will be our opposite. Okay, this side will be our opposite, then this side will be our adjacent. This is the longest side, which will be the hypotenuse. So from the trig ratios, we have the SOHCAHTOA right here. Okay, the SOHCAHTOA. So this is the trig ratio that we are using. So tan theta equal to opposite over adjacent. So opposite, so we have the angle 3 over 4. So the 3 will be on the opposite here. The 4 will be on the adjacent right here. So opposite over adjacent. That is how I've identified this angle to be, this number to be, and this number to be right here. So the question is, calculate the length of BD. Calculate the length of BD. So to find this length from here to here, we will just consider this as a right angled triangle. And since it's a right angled triangle, we have these sides. Okay, we have BC and we have side DC. We are going to apply what we call we are going to apply what we call the Pythagoras theorem. Okay, so since this is the hypotenuse, so if you are finding the hypotenuse using the Pythagoras theorem, you have to add the sum of the squares of the adjacent sides. Okay, that's what we do. So what are you going to do right here? You are going to say, to find BD, so this will be BD squared is equal to, you say BC squared plus CD squared, like this. Okay, so from here we can say BD squared is equal to, so BC is 4, so this will be 4 squared plus 3 squared. I hope you are following. So from here, BD squared is equal to 4 squared is 16, 4 times 4, plus 3 squared is 9, 3 times 3. So we are going to have BD squared is equal to 16 plus 9. This will give us 25. So we want to find BD. There's need for us to get rid of the square. So introduce a square root, even here a square root. Okay, so from here, what are we going to get? This and this will cancel. Therefore, BD is equal to the square root of 25. We are going to have plus or minus a 5. That is the square root of this. Now, we just say therefore, BD is equal to 5 centimeter. We get the positive value. 16, we are having question A and question B. So question 16 reads, two cylinders A and B are geometrically similar, and the ratio of their heights is m to 4. This is the ratio of their heights. Given that the areas of the cylinder A and cylinder B are 144 square centimeter and 256 square centimeter respectively, find the value of m. So what you need to do is this. So this is very simple. So let me do this. I just want to create enough space for answering. So we are going to start with question A. So here they have told us that you have two cylinders A and B. Okay, and their areas is 144. Okay, 144 and 256. So you put these as their ratio, 144 to 256. Okay, so since they are areas which are squared, okay, so what you do is you are going to find the square root of this, also find the square root of this. So the square root of 144, this will be a 12, to the square root of 256, this is 16. So after doing this, now the question is telling us to find the value of m. So their heights are written in this ratio, m to 4, m to 4. Okay, m to 4, that is their heights. Okay, so here when you look at the ratio of their volume is 12 to 16. So m to 4 is m to 4. This is what we are going to get. Okay, I hope that is clear. So from here, what we can do is we can try to multiply. Say m times 16, m times 16 equal to 12 times 4, 12 times 4. Okay, so what we are going to do is I'll divide by 16. Even here I'll divide by what? 16. So that this and this will cancel. Okay, so after cancelling, now we remain with m equal to, so you can check 4 here, it's a 1. 4 into 16, it's a 4. Okay, so we are remaining with 12 times 1, which will give us a 12 over a 4. So 4 here, 1. 4 into 12, it's a 3. So 1 into 3 will definitely get a what? 3. So the value of m is equal to 3. So we have answered our question B. Let us now answer our question B right here. Okay, so this is our question B. So under our question B reads, the diagram below shows a square-based right pyramid with an axis AB. Describe fully the symmetry of the pyramid. So the symmetry of this pyramid, we know that we are talking about the line that will cut this pyramid into equal parts. Okay, so no wonder we have this axis AB. So this is a square-based pyramid. So the square is right here down here, meaning that we know that a square, it's a four-sided polygon of which its length sides are equal. So the length from here to here and here to there, here to there, here to there, it's equal. Okay, so these length sides are saying they are equal. All right, so I hope you understand that. So the question is, describe fully the symmetry of the pyramid. So to describe fully this pyramid, since we are saying this is a four-sided polygon with all the lengths that are the same. So to describe this fully, we are just going to say the pyramid has four symmetry. Okay, so just say the pyramid has four symmetry. Okay, so this is our answer. We have described fully the symmetry of this pyramid. 17 reads, in the following diagram, A, B, C, and D are points on the circumference of the circle center O. So these points A, B, C, D, these are points on the circumference of this circle at the center O, right here. Okay, so BD is the diameter. This BD is the diameter which is cutting the circle. Okay, then AD is equal to AC. AD is equal to AC. So this simply tells you that we have an isosceles triangle right here. Okay, because the angle or the length of AD is equal to AC. So the angle which is right here is equal to the angle which is right here. And the angle BDC, angle BDC is equal to 22 degrees. Okay, so that is what we have. Let us now look at the questions. So these are the questions. Okay, find BAC, find BAC. So in order to find BAC is very easy. We are just going to say BAC is equal to 90 degrees. That is our answer there. Angle BAC is equal to 90 degrees because this BD is forming a diameter. It's a diameter. And if BD is a diameter, this is simply tell you that you are going to have a right angle triangle, this one, of which here we are going to have a 90 degrees right there. Okay, now let us come to the second one. Find CBD. Find CBD. Find CBD. Okay, so they want you to find an angle that will be right here. Find angle CBD. So how can we find the angle CBD? Okay, so to find angle CBD, this is very easy. So if remember what I said, that here we have a 90 degrees, not so here. So if we have a 90 degrees right here, simply means that even right here, okay, you're going to have a 90 degrees right here. So if we have a 90 degrees, we're going to treat this as a right angle. So if it is a right angle, you have 90, 22, then you have an angle that they want you to find right here. So when you add this angle and this angle, should have 90, then when you add this, you should have 100 and what? 180, yes. So what you are going to do is, since you know that even this and this should be 90, so just say this 90 minus 22, okay? The remaining angle is the angle which will be right there. So we're just going to say, for this one, we'll say we have 90 degrees minus 22 degrees. So this will give us what? 68 degrees. So here we're going to get 80 degrees. Okay, so the angle for CBD here, we're going to get 80 degrees right there. So we are done. Let us now move on to the third question right here, ACO. So they want you to find ACO. They want you to find ACO. So there are many ways, there are many things that you must consider in order for you to find this angle ACO. So one of the first thing is, remember this is a diameter BD, okay? So if it's a diameter, we are saying this distance from O to C is equal to O to D. So here we have something like this. We have equal distances like that, okay? I hope it's clear. So we are saying the distance of OD, which is a radius here, it's also equal to the distance OC, which is also a radius. So in order for us to find the ACO, first let us find what? This angle, which is the ACD. Let us find ACD. That is the first thing. Let's find the ACD. Okay, we find ACD. So how can we first find the ACD? The most important thing, let's take note of this angle, which is right here. Okay, so if you have a 22 degrees here, okay, this BDC is 22 degrees. So this is going to alternate with this, okay, angles in the same segment. So we are going to have a 22 degrees right here. All right, so the year 22, even year 22, I've said these are angles in the same segment, they are alternating, okay? So remember I said the whole angle here, it's a 90. So if you have a 22, it means that here, what angle are we going to have? Okay, what angle are we going to have? So it's very easy. Just say 90 minus this 22, not so. So we are going to have an angle of should be 68 degrees as well. Okay, so that is what we are going to get. All right, so I hope it's clear. So we have a 68 here. Now remember what I said, we find first ACD. Okay, so we have not yet found ACD. So this now will help us because this is an isosceles triangle. So we are talking about having something like this, okay, where you have a 68 right here, and this angle and this angle are equal. Okay, so let's say if you put a x angle here, even here x angle, when you say x plus x, this will be 2x, then plus this 68, then is equal to 180. So we have 2x is equal to 180 minus 68. So this will be 2x is equal to, now when you subtract 180 minus 68, you're going to get something like this, 112. You divide by 2, you also divide by 2. So this will cancel. We have x equal to, so here 1 here, we are going to get a 56 degrees. Okay, so we've gotten 56 degrees, meaning that here we are, I said ACD, so here we've gotten a 56 degrees. Okay, 56 degrees. So I hope it's clear. So if you have gotten a 56 degrees here and you want to find ACO, you want to find ACO, and here it's a 56. So what you are going to do is we are just going to do this. You say, okay, let me write here. ACO equal to, so I'm going to get this 6 degrees angle, okay, then we subtract 22 degrees right here, because I said this and this, they are the same. So if you have a 22 here, it means that even here you have a 22, but here you have said it's a 56. All right, so I hope it's clear. So what we have done is we found this ACD, we said it's 56, which is right here. Okay, so since here we are saying the distance from OD and OC, it's the same. So here we have 22, even here from here it's a 22, but this angle is 56. So if you have 22 here, to find this other one, just say 56 minus 22. Okay, so say 56 minus 22. Okay, then we are going to have say ACO, the angle which will remain here, equal to 56 minus 22. This is going to give us a 34 degrees. So this is our answer. Question 18. Y varies directly as x and inversely as the square of z, and y is equal to 8 when x is equal to 4 and z is equal to 1. Find the value of k, the constant of variation. B, find the value of y when x is equal to 9 and z is equal to 3. C, find the values of z when y is equal to 3 and x is equal to 54. So this is very simple. Okay, the most important thing is for you to come up with the equation of variation. Okay, in this case we'll go back to our question. It's saying y varies directly as x and inversely as the square of z. So the moment it says inversely, there's need for you to divide the square of z. Okay, so we'll need to do this. We're coming up with an equation that we're going to use. You'll say y varies directly. So here we introduce first the k, the constant, varies directly as x. So I'll write x here, and inversely. So and inversely I'll divide, and inversely as the square of z, as the square of z. So just say y equal to kx over z squared. This is what you are going to use. Okay, so we now answer our first question. We answer our first question. Find the value of k, the constant of variation. Okay, so to find the constant of variation, you are just going to use these values where they told you that they said y. Okay, let me just write them here. They said y is equal to 8, x is equal to 4, and z is equal to 1. These are the values that you have been given first. Okay, so we replace them here where there is y. We put 8 is equal to k is the one that we want. Okay, so there's no need for you to do anything. So on this k, don't do anything. So we're just going to write it the way it is, k times. So here the way it is, like kx simply means k times x. So what is the value of x? It's a 4. So it will be k times 4 over 1 squared, because z is 1. Okay, so from there, what are we going to do? This is very simple. I'm just going to say 8 is equal to k times 4. It's 4k. Okay, 1 squared is 1. So 1 into k times 4, you get the same k, 4k. So here you want to find the value of k. So we divide by 4. Even this side, we divide by 4. So this 4 and this 4 will cancel. Okay, you're going to remain with k is equal to, okay, so we say k is equal to 4 here, 1, 4 into 8, it's a 2. So the value of k, which is the constant of variation, is equal to 4. We have answered our first question there. We now come to question B. So in order to answer question B, let us look at the question right here. Find the value of y when x is equal to 4 and z is equal to 3. So we answer our question B, which will be answered right here. Okay. So here they have given you that find the value of y when x is equal to 9 and z is equal to 3. Then you have found your constant variation k, which is equal to what? 2. So first thing, don't forget the equation, okay? Don't forget this equation that you'll be using it, which is y equal to kx over z squared. So you want to find the value of this y. Replace here where you say y is equal to k, it's a 2, so it's 2 times, okay, then x, this x, it's 9, so it's 2 times 9 over z squared. So the value of z is a 3, so it will be 3 squared. Okay, so we say y equal to 2 times 9 over, now 3 squared means 3 times 3, okay, which will give us a 9. So you can see, let me cancel 9 here 1, 9 here 1, okay. So I remain with y equal to 2 times 1, it's a 2, divided by 1, which will still be a 2. So the value of y is equal to what? To 2. Okay, so we are just remaining with our question C, which is right here. Find the values of z when y is equal to 3 and x is equal to 4. So let me do this. You see clearly. So we are answering C. Find the values of z. They have said the values of z when y is equal to 3 and x is equal to 54. Then don't forget the constant variation, which is equal to 2. So the way these questions are, the moment you fail to find the correct answer for the constant of variation, it means you fail all these other questions. Okay, so let us come up with our equation. Okay, our equation is y equal to kx over z squared. This is our equation that we are using. Okay, so just replace. Okay, you replace where there is y, we are going to put 3. Where there is x, we are going to put 54. Where there is k, we put 2. But z doesn't have anything, so you say where there is y, we will put a 3 here equal to, where there is k, we are going to say 2 times, where there is x, it's a 54. So 2 times 54 over z squared. I hope this is clear. So from here, what are we going to do? Okay, what are we going to do from here? So it's very simple. Let's do this. All right, so from here, what are we going to do? It's very simple. Let's just do this. We divide by 1, then we close, multiply like this. Okay, so this is what we are going to do. We say 3 times z squared is equal to 2 times 54. So this is paper 1. Okay, so this is paper 1. Don't confuse yourself. So let me rewrite it this side so that, because they have got enough space, so we have 3 times z squared. Okay, this is z squared is equal to 2 times 54. So this is paper 1. Make sure that you are answering nicely so that you won't confuse yourself. I'll divide this side by 3, even here by 3, so that this 3 and this 3 will cancel. We'll get z squared is equal to, so 3 here 1, 3 into 54, it goes there 18 times. So 2 times 18, this will give us a 36. So I hope that we are moving together. So here I introduce the square root. Okay, introduce the square root, even here the square root. Therefore z is equal to plus or minus, what is the square root of 36? Is a 6. So remember the question was find the values of z. So this means z is equal to positive 6 or z is equal to negative 6. These are the values, okay? So let's just put here, we said z is equal to 6 or z is equal to negative 6. Then the first one here, the value of k was equal to 2. Then for the second one, we said the value of y was also equal to what? 2. Question 19, we have two questions. We have question A and question B. So we're going to start with question A. Solve the equation x raised to the power 1/3, 1/3 is equal to 9, okay? That is our first question that we are going to answer. Okay, so you can start answering question A. So I'll write the question, which is x raised to the power 1/3 is equal to 9, okay? So from there, what will be our next step? So how can you find the value of x? So since this x is raised to the power 1/3, we have to find the reciprocal of 1/3, which is 3/1, okay? So we are going to multiply 1/3 with its reciprocal, which is 3/1. So whatever we do on the left hand side, even to the right hand side, we do the same. So we write x to the power 1/3 times 3/1, or you just write 3, it's just fine, equal to 9 to the power 3/1, or just the power 3, it's just fine, okay? So from here you can see these powers. 3, it's a 1, 3, it's a 1, 1 times 1, it's 1, 1 times 1, it's 1. So we are remaining with just x equal to, this is 9 to the power 3. So 9 to the power 3 means 9 has to be multiplied by itself 3 times, okay? So we're going to have something like this. X is equal to 9 times 9 times 9, okay? So from here we are going to say x equal to, so 9 times 9, it's 81 times 9. So what will be our final answer? So just multiply 9 times 1, it's 9. 9 times 8, this is 72. So when you multiply 9 times 9 times 9, you're going to get 729. That will be the value of what? Of x. Now let us come to question B. Okay, so here is our question B right here. In the answer space below is an incomplete flowchart for calculating the height of a cylinder given its volume and radius. Complete the flowchart. So first thing, before we even complete the flowchart, we need to come up with the formula for the volume of the cylinder, which is volume is equal to pi r squared h. So they are saying in the answer space below is an incomplete flowchart for calculating the height. So they are calculating height. So it means that you have to make h the height the subject of the formula. Okay. So here we are going to divide by r squared. Even this side we divide by r squared. So this and this will cancel. You remain with height is equal to volume over by r squared. So this is your formula that you are going to use. Now, when it comes to the flowchart here, we need to understand something. We need to know the input, okay? So in this case, the input is going to be volume and what? Radius. This will be our input, okay? So let us come here. All right, so this is the flowchart. Okay, so here in this trapezium, in this parallelogram, we are going to say enter. So what are we going to enter? We're going to enter our input right here, and I've said our input will be the radius and the volume. So this is what you are going to enter there. After entering the radius and the volume, then here we are going to say we display the height is equal to volume over pi times radius times radius. So this is our answer. So question 20, we have two questions. Question A, points A and B have coordinates 2, -3 and 7,9 respectively. Find the length AB. Okay, so they want you to find the length of what? AB. That is what the question is asking. So how can we find the length AB? So we are starting with question A. So this is our question A right here. So first thing, let's take note of the coordinates that we have. We have 2, -3. Then we also have coordinate B, which is 7,9. Okay, so from this point, let us come up with the formula for finding the distance of AB, which is the length of AB. So length, or you can say distance of AB, is equal to, so the formula is the square root of x2 minus x1 squared plus y2 minus y1 in brackets squared. So this is our formula. Okay, so from here we are going to say equal to, so it's just a matter of substituting. So let's name our coordinates. This is x1, y1, this is x2, y2. So where there is x2, we are going to put here 7. Okay, so 7 minus what will be our x1, it's a 2 squared, plus what is our y2, it's 9, minus what is our y1, it's a -3. I'll put it in bracket like this, and then I cross squared. So from here we're going to have something like this, where we say 7 minus 2, it's 5. So it's 5 squared plus 9, the negative is a +3 squared. All right, so I hope that we are moving together. So from here, say 5 squared is 25 plus 9 times 3. Okay, it's 12. So here we are going to have 12 squared. So 12 squared means 12 times 12, which will give us what? 144. So we're going to have 25 plus 144 equal to, so it's just a matter of adding. Okay, 144 plus what? 25. Okay, so what do you get when you add this? 25 plus 144, you're going to get 169. So what is the square root of 169? It's 13. So since it's distance there, let's just put 13 units as our answer. Okay, so this is our answer. All right, so we now come to question B. Question B reads, given that y is equal to 4x cubed minus 3x squared plus 5x, find dy dx. So I'll write first the question. Y is equal to 4x raised to the power of 3 minus 3x squared. Then they say plus 5x. Okay, so how can we find dy dx? So dy dx simply means that you are differentiating this function with respect to what? To x. And one of the rules of differentiating a function, you can differentiate a function using a formula or just using the first principle. Okay, these are two ways you can differentiate a function. So here we say dy dx equal to, so to differentiate this function, you can see that it's 4x cubed. So this x is raised to the power of 3. So one of the rules of differentiating is that this power has to be multiplied with the coefficient of x, which is a 4. Then the power will be reduced by 1 as well. Okay, so we are going to write something like this: 4 times 3 in brackets, then x 3 minus 1. Okay, minus, again I'll say open bracket, 2 times 3, 2 times 3. Okay, then you are going to have x, then 2 minus 1. I hope that we are moving together. Okay, so from here we have plus 5x. So here this x is having a power of 1, but it's fine even if it's written x. You understand that here there is a power of what? Of 1. So what are we going to do here? We're just going to say plus. So this power of 1 will be multiplied by 5, so it will be 5 1 times 5. Then this x will be 1 minus 1, like that. Okay, so I hope you are able to see clearly what I've done here. This is 1 minus 1. Okay, so from here we are going to say dy dx equal to, so here 4 times 3 will get a 12x, 3 minus 1 to be power 2, minus 2 times 3 will be a 6x. Okay, so 2 minus 1 to be a power 1 on top. I can just write like that, it's fine. Then plus, so from here 1 times 5, it will be just a 5. Why? Because x is having 1 minus 1, which will be x raised to the power of 0, and x raised to the power of 0, it definitely give me a what? A 1. So that's why I've written here just a 5. Okay, so we have differentiated our function. Now come to question 21. Write down the 3 inequalities that define the unshaded region R on the diagram below. So here we have these inequalities, 1, 2, 3. We have these 3 lines that are representing inequality, and then we have this region that is marked what? R. So the question is asking us to come up with 3 inequalities that are going to define this unshaded what? Region R. Okay, so first thing, before you come up with inequalities, you have to first inspect your lines. Okay, what I mean by saying inspecting your lines, you check which one is simple. Okay, so let us look at this line which is okay, so these are the coordinates 7, 7, meaning this is the x coordinate 7 and this is the y coordinate 7. So it means at this point it's 7. Okay, this is the point 7. X is equal to 7. This one, x equal to 7. Okay, then even this one, y is equal to 7, which is corresponding to this side. Okay, so upon identifying that, so our first inequality, we are going to say we can come up with our first inequality for this line 1. We name it as line 1, where we say x, we leave space here, then we write 7. Okay, then we write 7. So let us see. We want to define the unshaded region. Okay, so look at this type of the line. It's a dotted line. Okay, it's a dotted line. So this inequality is going to be either less than, okay, or it's going to be greater than. It's not going to be equal to, because the line is what? Dotted. So what you do is the unshaded region is this side. Okay, we know that here we are saying the values going this side, they are greater than 7. The values going this side, they are less than 7. So we are defining this inequality using the unshaded part. So x is less than what? 7. This is our first what? Inequality. X is less than 7. Okay, I hope it's clear. We move on. Okay, we now come to the second line. So for this one, since both this line and this line, you can pick any of the two. So let me say I pick this one. Okay, this one which is passing right here. So for this one also, I'll take note of the coordinates. I've got this coordinate which is 1, 1, then 7, 3. So that is my area of interest, the coordinates. So I'll name this as coordinate A, then I'll name this as coordinate what? B. So upon doing this, let us now find the gradient of this line. Okay, let us find the gradient of this line. I hope it's clear. So what we are going to do is this. We are saying we have coordinate A, which is 1, 1. Then we also have coordinate B, which is 7, 3. Okay, this is coordinate B. So this will be your x1, y1. This will be your x2, y2. So I want to find the gradient of this. Okay, so what you are going to do is you are going to say gradient is equal to y2 minus y1 over x2 minus x1. Okay, so I hope that it's clear. That is what you are going to do. Okay, so from there, then you say m is equal to, my y2 is a 3, my y1 is a 1. So it's 3 minus 1 over my x2 is a 7, my x1 is 1. So it's 7 minus 1. So 3 minus 1 is 2 over 7 minus 1 is 6. Okay, so we can simplify this where we say 2 into itself it's 1, 2 into 6 it's 3. So the gradient will be 1/3. This is our gradient, 1 over 3. So upon identifying our gradient now, since we want to find the equation for this line right here, this line, okay, so we are going to say, let us come up with a equation of a straight line. We are going to use this one where you say y minus y1 equal to m open bracket x minus x1, like this. So here, since you have these two coordinates, this and this, you can pick any. So I'll pick this one, which is having minimum values. So I'll say 1, 1. So this one will be my x1, this will be my y1. Then m is standing in for gradient, which is 1 over 3. So just substitute. Okay, so you say y minus, where there is the y1 right here, you put this one. Okay, so mind you, you can pick any of the coordinates. If you want, you can even pick this. You get the same answer. It's fine. Equal to, where there is m, I'll put 1 over 3. This is our gradient, which was right here, open bracket. Then x minus, my x1 is the one right there, like this. Okay, so it's just a matter of say y minus 1 equal to 1 over 3 times x. So we're going to have 1 over 3 x. Then 1 over 3 times a negative 1, you still get a negative 1 over 3, like this. Okay, so from here, we can do this. We say y equal to 1 over 3x minus 1 over 3. So this negative 1 will come this side. It will be a positive 1, like this. Okay, that is what we have. 1 over 3x minus 1 over 3 plus 1. So this plus 1 is coming from this side. Okay, so here what we can do is this. You say y equal to 1 over 3x. Okay, so this is negative 1 over 3 plus 1. Negative 1 over 3 plus 1. What are we going to get? Alright, so when we add negative 1 over 3 plus 1, this will give us a positive 2 over 3. Alright, so we have not yet answered our question fully. So what we do is we need to use the inequality sign. So we say y, we leave space here. This is an equation now. I want to leave it as an inequality with a symbol. 1 over 3x plus 2 over 3. So what inequality sign are we going to put? So to know which inequality sign we are going to put, let us go back to our line. Let us check. This is our line. Okay, so the line that we are answering for is this one. Okay, so this will be named as our line 2. It's this one. So this line is not a dotted line. It's a solid line. You can see it's not broken or it's not dotted. Okay, so it means your inequality should be equal to. Okay, it can either be greater than or equal to, or less than or equal to. Now, want to describe the unshaded region. So the unshaded region is this region which is above. Then the shaded region is this region which is down. So how can we which inequality sign are we going to put? So this upper region, the upper region is what? Is greater. Okay, then the lower region is less. So we are going to say this is greater than or equal to. That's what we are going to use as our inequality sign right here. Okay, so we come back. Okay, so here we have said you use greater or equal to. So this is our answer. So I hope that it's clear. Okay, we now move on to our last part. So this is our last line. As you can see it, name it as line 3. Okay, this is our line 3. Now for this line, let us check the coordinates. We use this one 1,1, then and these other coordinates 7,7. Okay, so we say C we have 1,1, then D coordinates we have 7,7. Okay, so from here what you can do, find the gradient of this line. So we say M equal to, so I do hope that we are moving together. M is equal to y2 minus y1. Y2, okay, let us rename them x1, y1, x2, y2. So my y2 is a 7, my y1 is a 1 over my x2 is a 7, my x1 is a 1. So when you do the calculations here, 7 minus 1, it's 6. You're having a 6 right here over 7 minus 1, it's a 6. 6 into 6, it's 1. The gradient is 1, okay? So let us just say y minus y1 equal to m open bracket. So I know why I'm solving this. You can just go straight following one of the laws of the graph, okay, which says this line is y is equal to x. But I want us to solve just in case you come across a different line. You can be using this. So m then x minus x1 you cross. So we can pick any of the coordinates. I'll pick this easiest one. So I'll say y minus 1, because y1 will be this. My gradient is 1 open bracket x minus 1, because my x1 is the same one. I've used these coordinates right here. Okay, so from here we are going to have y minus 1. All right, we are going to have y minus 1 equal to x minus 1, because 1 times x is x, 1 times negative 1 is a negative 1. So from here we are going to have y is equal to x minus 1 plus 1. Okay, because this negative x, once it goes this side, becomes a positive. So from here we're going to have y is equal to x, because negative 1 plus 1, it will be a 0. Okay, so this will give us y. We leave space right here, and then we just write x. Now, which inequality sign are we going to use? We come back to our diagram. This is the line. Now, what type of a line is it? You can check. It's a solid line, and it's the upper region that is shaded. Now I want to describe the unshaded region, which is the lower. Okay, so the upper region is greater, the lower region is less. So the unshaded region is less. So because the line is solid, so it will be less than or equal to. Okay, so from here we are going to write our answer here, which is going to be less than or equal to as our answer right there. Alright guys, we've now come to question 22. So question 22a, the components of the vectors OA and OB are 2, 3 and 4, 2 respectively. So this is for the component of vector OA, this one is for OB. Write down BA as a column vector. Okay, so I want you to write BA as a column vector. So we are answering our question A right here. So before I answer, it's very important that you come up with a sketch. So this is the origin, okay? So if this is the origin, we are going to have the point A right here, and we are going to have the point B right here. So OA, then OB, like this. Now they want you to find BA, okay? So we are going to move BO plus OA. So this is what we are going to do, right? Say, okay, we are going to say BA is equal to, I've said BO, then plus OA, like this. So I hope it's clear there. Okay, so from here what we are going to do is this: BA is equal to, so let me write from this side. I'll continue this side, okay, because of space. So BA is equal to, so now my OB is this, okay? But if it's BO, it's against the direction, so it will have a negative like this, negative 4, then 2. Yeah, this is my OB, this one right here, sorry for that. Then plus, then my OA is this one right here, which is 2, 3, like this. So I hope we are moving together. So from here, this is what we are going to do. This will be negative 4, and this is a negative 2, right, like this, okay? Then plus 2, 3. So what will be our final answer? You can say therefore BA is equal to, you can say negative 4 plus 2. This will give us a negative 2. The negative 2 plus 1, sorry, plus 3. This will give us a 1. So this will be our answer. Okay, this is how we are going to write BA as a column vector. I hope it's clear. We now move on to question B. The question is right here. The diagram shows the sketch of the graph of y is equal to 3 minus 2x minus x squared passing through A, B, C. So you can see we have the points A, B, C. So this is the parabola. We are looking at the y-intercept. Okay, so from here, what are we going to look at? Find the Roman numeral 1. Find the coordinates of the points A and C. A and C. Roman numeral 2. Find the turning points of the graph. Okay, so I want you to pay attention. Okay, how can we find the coordinates of the turning point for A and B? Okay, all right, so allow me to just demarcate the space like this. Yeah, so we are going to start from you say you're answering for Roman numeral 1 like this. So first thing, let us write the general equation that we have been given, which is y is equal to 3 minus 2x minus x squared. This is the general equation of this sketch. This one right here, you can see here they have been marked like that. So from there, what you can do is you can either consider the line. This line is y is equal to 0. You can consider this y is equal to 0. So where there is this y, you are going to put a 0. Then you can try to factorize this, okay, using the product and the sum method. You are still going to get the same answer. Or you can use the formula method, okay, whereby we find just the value of x. So this is a quadratic equation, so it will give us 2 values of x. I think let us use the formula so that we move fast. So the formula will be x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. So from this quadratic equation that we have, okay, we know that this is going to be a, b, c. Okay, so the coefficient of x squared is a negative 1. The coefficient of this x is a negative 2. So here the b will be a negative 2. The a will be negative 1. Then c is the constant, which is a positive 3 right there. So let us just substitute. We're going to have x is equal to, so b I've said is a negative 2 right there. So it will be negative, which is this one outside. And then we put negative 2 in brackets, plus or minus, come up with this, where we say negative 2 squared minus 4. My a is a negative 1. Then my c will be a 3 like this. Okay, then we say over 2. Then what is our a? It's a negative 1 right here like this. So from there, what are we going to have? X is equal to, so negative negative positive is 2 plus or minus square root of negative 2 squared. This will be a 4. The negative negative, it's a positive. 4 times 1 times 3, we're going to get a 12 over 2 times negative 1, we'll get a negative 2 like this. Okay, so from here we'll say x is equal to 2 plus or minus, then the square root of 4 plus 12. This will give us a 16 over a negative 2. Okay, I hope we are moving together. So x is equal to 2 plus or minus, what is the square root of 16? It's a 4. Okay, over a negative 2, like this. Okay, so from here, let me just write here. Let me do this. Okay, so from here we can separate x is equal to 2 plus 4 over negative 2, or we can say x equal to, so what do we have? We have a 2 minus 4 over negative 2, like this. So from here we say x equal to, so 2 plus 4, it's a 6 over negative 2, or x equal to 2 minus 4, it will be a negative 2 over negative 2. Okay, so our final answers, x is equal to 2 here, 1, 2 into 6, it's a 3. So we have a negative 3, or x equal to this negative 1, this negative out, 2 into 2, it's a 1 right here. So these are the values of what? Of x. X is equal to negative 3, or x is equal to what? To 1. Okay, x is equal to negative 3, or x is equal to 1. Now they said find the coordinates. Find the coordinates of point A and point C. So let us come back to our question right here. Okay, this is our question right here. So I said this is the line y equal to 0. Okay, so our coordinate A is right there, our coordinate C is right here. So we're going to say therefore A, so you can see A is on the negative side. Okay, and we said the x is equal to negative 3 or 1, so it will be negative 3 comma 0. Okay, then for C it's 1 comma 0. So these are the coordinates of point A and point what? Point C. In case you are wondering where is the 0 coming from, we said the A and C are lying on this line, which is y is equal to 0. Okay, I hope it's clear. Let us now come to question B, Roman numeral 2, which is right here. Find the turning point of the graph. Find the turning point of the graph. So they want you to find the turning point of this graph right here, this turning point. Okay, this is what they want you to find. What coordinates, what was the turning point of this graph? Okay, so meaning there's need for you to come up with the x coordinate and the y coordinate there. Okay, so here to find the turning point of the graph, we can just use a very simple formula. Okay, we can use a very simple formula where we say Roman numeral 2. So this simple formula, we have one for x coordinate and the one for y coordinate. So for x coordinate, we can use this formula where we say x is equal to negative b over 2a. Okay, that is what you can use, negative b over 2a. So what is your equation? Your equation is this one. Okay, this is your equation. Okay, and if you look here, we did name that this is a, b, c. So my a is a negative 1. Okay, my a is a negative 1. Then what will be my b? It is a negative 2 from this. That is what we said from this general equation that we have been given. So just substitute here where you say x equal to, so negative, so b is a negative 2, so put a negative there, this one on the formula, and then negative 2 in brackets over 2, then a is a negative 1, like that. So we are going to have x equal to negative, it's a positive 2 over 2 times negative 1. This will give us a negative 2. So definitely x coordinate is equal to negative 1. This is our x coordinate. Okay, so now there's need for us to find the y coordinate. Okay, so how are we going to find the y coordinate. So to find the y coordinates is very easy as well. Okay, so what are we going to do? Yeah, okay, let's do this. All right, so we have found that our x coordinate is -1. Okay, then let us find our y coordinate. So this is our equation. So this is a, b, c. So my a is a -1, our b is a -2, c is a 3. So even for the y coordinate, we can come up with a formula which is y is equal to, okay, so this formula is 4ac minus b squared over 4a. Okay, so from here, this is what we're going to have. We say y is equal to, so it's just a matter of substituting, where we say 4 in bracket, where there is a, we put a -1 close, where there is c, we put a 3 like this, minus, so b is a -2, so it will be in bracket -2 squared over 4, a is a -1 like this. So I'm just substituting here. So what you do is y is equal to 4 times -1 times 3. This will give us a -12 minus -2 to the power 2. This is 4, okay, over 4 times -1. This will be a -4 like this. So y equal to -12 minus 4. This will be a -16 over a -4. So from here, we cancel negative and negative out. Y is equal to, for here 1, for here it's a 4. So y is equal to what? To 4. Therefore, the coordinates of the turning point, will be equal to, remember our x was -1, our y is a 4. So this is our answer. All right, guys, so we have now come to our last question for this lesson, question 23. The following diagram is the speed time graph of a car. So this is the speed time graph of a car. So calculate the acceleration of the car during the first 5 seconds. Acceleration of the car during the first 5 seconds. So this car was started accelerating from here on this speed 0 meters per second, and the time was 0 seconds. Then started going up. It was accelerating, okay, in the first 5 seconds. So to answer this question, there is need for us to come up with the formula. Okay, so this is how we are going to answer it. We are answering question A. So you say acceleration is equal to final velocity minus initial velocity over time. So from here, we are going to say acceleration is equal to my final velocity. Let us come back to our diagram. The initial velocity will be 0 meters per second. The final velocity will be a 20, which is right here. Okay, then we do this. So final velocity, it's a 20 minus the initial velocity, which is a 0, over the time they have said in the first 5 seconds. So there we say acceleration is equal to 20 over 5, because 0 minus 20 is a 20, then over 5. So from here, acceleration is equal to 5 here, it's a 1, 5 into 20, it's a 4. So we're going to have 4 meters per second square as your acceleration there. Okay, now let us look at our question B. Let us look at our question B right here. So this is our question B. Find the value of t given that the total distance traveled was 550 meters. So the total distance for the whole journey was 550 meters. They want you to find the value of this t. So when you look at this shape, okay, this shape right here, this is a trapezium, okay? So we're going to consider the area or the distance under this shape, okay? So they have told you that the total distance traveled was 550. So this is a trapezium. Assume that you are finding the area of this trapezium, which is the distance in this case. So distance, okay, so this is for question B, is equal to, we say, a plus b cross bracket h over 2. Now, here, from here to here, this is where we are going to have our A right here. Then this is our B. Our height will be from here to there. Okay, this will be our height. So our A, I've said, is from here to here, of which we are going to find the difference in time. So here you have 25, here you have a 5. So 25 minus 5, this will be a 20. So A will be equal to 20 right there. Then for B is from here up to here. This is for B, from here up to here. So the difference will be from here to here, we have t minus 0 seconds is t. So B will be equal to what? To t. The height from here to here, which is corresponding to this speed right here, which is 20. So height will be equal to what? 20. So just substitute now in your formula there. Just substitute. So where there is d, they have told you that the total distance was 450 meters. You write 550 equal to A, it's a 20, plus B, it's a t, cross over 2 times the height here is a 20. Okay, so what do you do now? The height is a 20. You can say here 1, here it's 10, like this. Okay, so we are going to have something like this. 550 is equal to, so from here we have 20 plus t, then we have the 10 right here, the 10 outside right there. Okay, so I do hope that it's clear. Okay, I do hope that it's clear, you are following, there's no one who's behind. All right, so I believe we can continue. You can see we have a 10 here. You do divide 10, even this side you divide 10. So this 10 and this 10 out, this out. So what are we remaining with? We are remaining with 20 plus t is equal to 55. So let us correct the right terms. So I say t is equal to this 55 minus a 20. So the value of t will be equal to 55 minus 20. This will be 5 minus 0, it's 5. 5 minus 2, it's a 3. So this will give us 35 seconds. This will be our value for t. So t is equal to 35 what? Seconds, right? So let us now come to the last question, which is on question C right here. Calculate the average speed for the whole journey. So they want you to find the average speed for the whole journey. So this one, just come up with the formula for finding speed. Okay, so which is very, very easy. So we are answering for C. So just say speed is equal to distance over time. So speed is equal to your distance. They have told you that the distance for the whole journey was 550 over time is this one, which is 35 seconds, like this. Okay, so this is paper 1. Just find the number that can go into 55 and 35. Let's say 5 into 55, it's 11, so it's 110 over 5 into this, it's a 7. Okay, so from here, this is what you are going to do, where we say 7 here, 1, 7 into 11, it's a 1. Okay, so what will be our remainder? The remainder is a 4, so 4 and a 0. Okay, so here we just say 7 into 40. All right, so this will give us a 15. Okay, because 7 into 40, it's 5. So this will give us a 15. Then the remainder is going to be 5. Okay, the remainder will be a 5. 7 into 5, it can't. 7 into 50, it's 7. All right, so let's just leave our answer at this stage, where we said we are going to have 110 over 7. So this is speed, you just say meters per second. So we leave our answer at this stage, is fine. Okay, just like that. All right, so thank you so much, everyone. We've come to the end of our program. So let me just fill in here. We said acceleration is equal to 4 meters per second square. For B, we are finding the value of t, where I've said t is equal to 35 seconds. The last one, speed is equal to 110 over 7 meters per second. Okay, like this. So thank you so much, everyone, for having time to view this content. Please feel free to leave a comment and subscribe to my YouTube channel. Bye bye.